Welcome to the debate. Imagine spending $50 million and, let's say, 3 years to totally upgrade your massive organization's digital nervous system. You're fully expecting to unlock this whole new era of artificial intelligence and real-time analytics.
Right, the absolute dream scenario vendors sell you.
Exactly. But on day one, you discover that, I don't know, 100 lines of custom code written by some well-meaning developer a decade ago to fix a really minor local accounting issue has just completely paralyzed your system's ability to communicate with modern AI tools.
Yeah, it's a nightmare scenario. But for a lot of global organizations right now, it is their everyday reality.
It really is. And that reality is forcing this massive architectural reckoning, which is what we're looking at today. Specifically, SAP's clean core architecture and its broader role in modern enterprise environments.
Right, because when global companies migrate to these modern ERP systems, and for anyone listening, that's enterprise resource planning software, the central brains that run everything from HR to supply chain, so your S/4HANAs or Oracle Fusions, the vendors are increasingly demanding that the core software remains strictly, entirely unmodified.
They are. Which brings us to the central question before us today. Is maintaining a strictly unmodified ERP system truly the non-negotiable architectural foundation for AI and business agility?
Or, and this is where I come in, does the whole concept of a clean core simply shift inevitable, totally unavoidable business complexities and the massive technical debt that comes with them out of the core and just dump them into external integration layers?
It's a great question, and we're drawing this debate directly from current architectural documentation on the intelligent enterprise, which is basically the blueprint for how businesses are going to deploy tech over the next decade.
Yeah, it's the defining document for this space.
So I'll be taking the position that a clean core is an absolute architectural prerequisite. Every customization you embed directly into the software's core is essentially a mortgage on your future capabilities. It actively prevents AI readiness, it destroys your ability to upgrade, and honestly, it makes real-time compliance basically impossible.
And I'll be representing the perspective that the gap between what standard ERP software does right out of the box and the actual boots-on-the-ground reality of running a complex global business is entirely legitimate. I'll argue that shifting custom logic into an external environment, what we often call a data orchestration layer, does not magically eliminate the expense or, the ongoing maintenance obligations of that complexity.
All right, so let's ground this in exactly what we mean when we talk about breaking the core. From my perspective, based on the architectural material, a clean core isn't just a polite vendor recommendation. It's a fundamental philosophy about where business logic is allowed to live.
Right, because historically, if a standard ERP didn't do exactly what a business wanted, developers would just write what SAP calls Z programs.
Exactly. Z programs, which are essentially custom-coded workarounds injected straight into the software's foundational source code. They create custom tables, unique country-specific configurations, all these bespoke workflows that are hard-coded right into the heart of the system.
Which the business usually demanded, by the way.
Oh, sure, they demanded it. But by doing this, organizations completely contaminate their system of record. They build this compounding mountain of technical debt. I would argue that an unmodified ERP generating standard, clean, predictable transactional data is the only viable way to scale an organization today. If you break the core with custom code, you break your future agility.
Look, I understand the appeal of that pristine engineering vision. It sounds great on a whiteboard, right? And I approach this issue with deep respect for the standard model. There's no denying that an unmodified ERP is vastly easier to update.
Vastly easier.
But we have to look at this with intellectual humility. If you're listening to this and thinking, well, my business is too complex for a standard out-of-the-box system, you aren't alone. Business requirements are undeniably real. Varied tax laws across 50 jurisdictions, highly specific pharmaceutical traceability rules, really intricate multi-entity corporate structures. They aren't going away just because IT wants a clean system.
Nobody's saying they go away.
But moving this necessary logic from the ERP to dedicated external layers still requires bespoke transformation. It still requires complex digital bridges or APIs to connect that external logic back to the main system. As the material explicitly points out, both options are expensive and both create massive ongoing maintenance obligations. You aren't eliminating the debt, you're just moving it to another server.
Well, but moving it changes the fundamental nature of the risk. We need to look closely at how customization debt actually behaves inside the ERP. It isn't linear. It doesn't just add up, it compounds exponentially.
How so?
Well, if you have a legacy environment, your first custom table adds a constraint. Fine, but the second custom workaround inevitably interacts with the first. By the time your business is 10 years old, you've woven this dense web of undocumented interactions that literally no single person in the entire organization fully understands.
Yeah, that is the reality of legacy systems. The interactions become incredibly dense. I'll give you that.
And because of that density, think about what happens when SAP or Oracle releases a critical software upgrade. In a standard system, an update is a routine procedure. In a highly customized system, every single upgrade becomes a massive, terrifying regression test.
It's an event.
It's a huge event. You have to pull 50 key business users away from their days jobs for 6 months just to manually test every custom workflow, just to ensure the new vendor update didn't quietly sever a connection to your warehouse database. The upgrade ceases to be a software change, it becomes a multi-million-dollar excavation project. And that is exactly why highly customized organizations stop upgrading. They just become frozen in time.
I come at it from a different way, though. I look at why those custom tables and workarounds exist in the first place. This pressure to customize doesn't just come from developers wanting to tinker and build little empires. There is a fundamental, legitimate gap between the software and the real world.
Sure, the standard system cannot be everything to everyone.
Right. Let's say you operate a telecom business in Brazil. The revenue recognition rules and tax invoicing requirements there are staggeringly complex and entirely unique to that geography. No standard global ERP covers every single local regulatory requirement natively out of the box.
No, they don't.
So if a company externalizes this Brazilian tax logic to adhere to this clean core philosophy, what are they actually doing? They're simply moving that necessary custom logic to another platform. They still have to write the code to calculate the tax. They still have to test the logic. They still have to maintain those custom business rules every time the Brazilian government changes its mind. The labor and the complexity haven't vanished at all.
That's an interesting point, though. I would definitely frame it differently. The labor still exists, yes, but the isolation of that labor is what saves the architecture. Let's use a physical analogy.
Okay, go for it.
If you buy a house, you expect standard electrical outlets in the wall. When you buy a new television, you simply plug it into the standard outlet. Customizing the ERP core is like deciding you don't like the outlet, tearing open the drywall, and hardwiring your television directly into the house's main electrical grid.
Because in this scenario, the standard outlet doesn't provide the right voltage for the specific appliance the business actually needs to run.
Exactly. But if you hardwire it directly into the wall, what happens when you need to upgrade the house's electrical panel? You can't. The television is inextricably tied to the house's infrastructure. You have to tear the walls down again.
Right, it's a mess.
The clean core philosophy says, keep the outlet standard. If you need a specialized voltage for a specific machine, like your Brazilian tax logic, build an external adapter. Plug the adapter into the standard outlet and plug the machine into the adapter. The specific logic lives in the external adapter, leaving the house's main wiring completely standard, safe, and easy to upgrade.
Sure, but what if your business is heavy manufacturing and you don't just need a television, you need an industrial arc welder?
Well,
If you try to run that through a standard outlet with an external adapter, the integration point just melts. You are relying entirely on the adapter, the API, the digital bridge to handle a massive, mission-critical load perfectly every single time.
but if you don't build that adapter, your inability to update the main system leads us directly to a structural nightmare. Let's look at how this inability to upgrade collides with the modern regulatory environment. Specifically, let's talk about continuous transaction controls, or CTCs.
Oh, right. This is where governments are fundamentally changing how corporate tax and invoicing work.
Precisely. CTCs require compliance logic to be executed at the exact millisecond of a transaction. The government wants to see, validate, and approve the invoice before the physical truck is even allowed to leave your warehouse.
Which is a huge shift.
It's massive. And if your ERP is bogged down by years of hardwired customizations, it simply cannot be updated fast enough to keep pace with these overnight regulatory shifts. Its customization layer was never built for real-time external communication with government servers.
I see where you're going with this.
Right. So by utilizing an external orchestration layer, an adapter, adding a new tax jurisdiction becomes a simple configuration task in a system built for agility, rather than doing a massive course surgery in a system designed for stability.
I'm sorry, but I just don't buy that. Let me tell you why. You're presenting the external layer as this frictionless, easy adapter. But the architectural material we're referencing provides an explicit warning on this exact topic. It states quite clearly that building a separate integration that bypasses the ERP logic is highly expensive and complex. We have to be honest about the mechanics of how these systems actually talk to each other.
You mean the APIs?
Yes, the application programming interfaces, the digital bridges. If we use an external layer for CTCs, consider the latency and the actual operational risk. A worker tries to generate an invoice. The ERP has to stop. It packages the raw data. It fires that data over an API to an external data orchestration layer.
That's right.
Then that external server unpacks it, runs the custom tax logic, reformats it, opens another connection to the government platform, waits for a cryptographic response, routes that approval back to the external layer, which then passes it back over the API to the ERP, which finally lets the truck leave the warehouse.
Yeah, I mean, that is the standard flow of modern microservices.
But haven't we just created a highly vulnerable new bottleneck? You've decoupled the logic, sure, but the complexity of the network architecture has just skyrocketed. If any one of those digital bridges experiences a timeout or an API format changes slightly, the whole supply chain stops. You are trading customization debt inside the software for integration complexity across a network.
I see why you think that, but let me give you a different perspective. Yes, the network architecture introduces new API pathways, absolutely, but it solves a much deadlier structural dilemma. If you build that real-time compliance logic inside the ERP, you are adding to the very customization burden that makes adapting to the next regulatory change impossible.
It's a trade-off, for sure.
But it's a necessary one. The external compliance layer is purpose-built to handle the complexity, the variability, and the sheer velocity of change that characterizes modern global regulations. The ERP's only job is to generate standard transaction data and pass it through a universal outlet. It isolates the chaos of global regulations from the foundational stability of your financial system of record.
Well, while keeping up with the government keeps the company legal, I think we both agree that the true strategic battleground for the next decade isn't just tax routing.
No, it's artificial intelligence.
Exactly. Beyond basic compliance, how does a clean core philosophy genuinely dictate the deployment of AI across an enterprise?
This is, without a doubt, the most critical point of the entire architectural shift. We're moving toward what the material calls the Internet of Agents.
Right? Distributed AI.
Yeah. Specialized AI systems operating autonomously across financial and operational processes. You might have a supply chain AI agent negotiating in real time with a logistics AI agent to reroute shipments. These agents operate at machine speed, and because they operate autonomously, they require absolutely clean, standardized, machine-readable data.
Which legacy, highly customized ERPs famously do not produce.
Exactly, because human users have an incredible capacity for interpretive work. If a human accountant looks at a customized ERP screen and sees a data field labeled MISC01.
Oh, the dreaded MISC01 field.
We've all seen it. So they see MISC01, which has been used to track marketing spend for the last 10 years because of some old Z program. The human figures it out. They know what it means through institutional memory. Autonomous agents do not have that interpretive capacity. They look for standardized tags.
Right, they read the metadata completely literally.
They read it literally, so the AI reads MISC01, assumes it is irrelevant, miscellaneous data, and quietly excludes millions of dollars of marketing spend from your real-time financial forecast. We call this failing silently. If AI agents are fed proprietary, contaminated data structures born from years of hardwired core customizations, they're going to generate highly confident, entirely incorrect outputs at a massive scale before a human ever has the chance to intervene.
That's a really compelling argument, and the MISC O1 problem is a very real threat to AI forecasting. But have you considered exactly how the architectural material describes the solution to that data problem?
What do you mean?
Well, the documentation specifically states that it is the data orchestration layer, the external middleware, that is responsible for standardizing and validating data before it ever reaches consuming AI agents.
Yes, it sits between the systems of record and the AI.
Right, it's the integration hub through which all data flows, getting mapped, normalized, and routed. Therefore, it's this middleware that is doing the heavy lifting for AI preparation. If the middleware is translating MISC 01 into standard marketing spend language for the AI, then the ERP itself doesn't magically solve the AI data problem just by being strictly unmodified. You still need that massive external orchestration layer to prep the data.
I'm not convinced by that line of reasoning because it ignores the fundamental source of the contamination, and honestly, it overestimates what middleware can actually do. Middleware is not magic. It cannot read minds. It relies on predictable inputs to execute its translations.
Sure, it needs a rule set.
Exactly. If the root data generated by the ERP is semantically corrupted, if the same data field means 3 different things in 3 different regional business units because of deeply embedded country-specific configurations, the orchestration layer cannot effectively untangle it.
You're saying the translation layer fails if the source language is broken?
Exactly. The ERP must provide a clean baseline as a default output of its standard operations. If the foundation is distorted, the orchestration layer spends all of its computational power and architectural complexity just trying to reverse engineer the customized mess. For AI capabilities like anomaly detection and supply chain forecasting to function reliably, the core system of record must generate data that is semantically coherent from the absolute moment of creation. AI demands a clean core.
But let's ground this back in the reality of the business world. We're discussing the ideal AI architecture here, but we have to face the accumulated reality of most large organizations. A greenfield rebuild, where a company just wipes the slate clean, deletes decades of custom code and starts from a perfectly standard ERP, is a sheer impossibility.
Nobody is suggesting they do it overnight.
But they have years of accumulated necessary business requirements embedded in those systems. You cannot just walk up to a business unit and tell them they are losing a critical operational process tomorrow because it doesn't fit the new clean paradigm. So how does an organization actually achieve this without grinding their daily operations to an absolute halt?
That is the practical crux of the issue, and you're entirely right. You cannot fix everything at once. The source material directly addresses this by advocating for a strategy called progressive externalization.
Meaning doing it in pieces over time?
Yes. Major ERP migrations, like the current wave of organizations moving from legacy SAP systems to S/4HANA, represent a natural, unavoidable inflection point. When you execute that migration, you don't just lift and shift the old customizations into the new system. You use the migration as an audit.
To find the worst offenders.
Exactly. You identify the highest cost, most constraining customizations first. Then, you incrementally rebuild that specific reporting or validation logic in the external layers, like the SAP Business Technology Platform. You build the adapter layers to absorb functionality piece by piece, rather than demanding a day-one greenfield utopia.
So it's fundamentally a transitional discipline. You freeze the core system from any new customizations, and bit by bit, you strangle the legacy code by rebuilding its functionality in the external environment.
That's the plan.
But let's be clear about what that progressive externalization actually demands from a business. It means maintaining 2 operational paradigms simultaneously during a transition that could take years.
It is absolutely a dual maintenance period. There's no denying that.
The organization has to fund the core ERP migration, they have to fund the development of the new external layers, and they have to fund the intricate temporary APIs that connect the old processes to the new architecture while the transition happens. It requires an immense amount of architectural discipline and budget that many organizations frankly struggle to maintain when project fatigue inevitably sets in.
It does require relentless discipline, but let's summarize exactly what is at stake here. From the perspective I've argued today, Clean Core is not a constraint on the business's ability to operate. It is strictly a constraint on where the digital logic is allowed to live. It's the necessary starting point, not the end state.
Right.
By tearing out the hardwired code and ensuring the ERP remains a standard, universal outlet generating predictable data, an organization dictates its own future. It determines whether its technology investments for the next decade will build upon a solid foundation or whether it will constantly fight against a suffocating web of technical debt. A clean core is the non-negotiable architectural prerequisite for deploying reliable AI agents, achieving real-time global compliance, and maintaining the agility to upgrade your systems without fear.
And to summarize my perspective, while maintaining a standard, pristine system of record is undeniably a powerful engineering goal, organizations must remain incredibly clear-eyed about the trade-offs of this shift. Externalizing business logic does not erase the complexity of your business. The varied tax laws, the bespoke industry processes, the unique regional workflows, they still exist and they still need to be coded somewhere.
Very true.
The ongoing maintenance obligations, the development costs, and the risk of system failure simply shift from the ERP core to the data orchestration and compliance layers. You're trading customization debt for integration complexity, relying on a vast network of APIs to do the heavy lifting, and both approaches demand rigorous, ongoing financial and technical investment.
I think where we fundamentally converge today is on the undeniable gravity of this architectural choice. The decisions being made right now by IT leaders regarding exactly where to place custom logic will definitively shape and perhaps permanently limit an organization's ability to deploy real-time AI and continuous financial intelligence in the years to come.
Agreed. Examining both the undeniable capabilities unlocked by a clean core alongside the very real practical burdens of the external integration layers it mandates truly illuminates the true cost of enterprise architecture. There is no free lunch in enterprise tech, and there's so much more to explore in this material, particularly regarding how those intelligent agent frameworks will actually negotiate with each other across these complex data orchestration layers once this architecture is fully in place.
Absolutely. Ultimately, whether you view the ERP core as the foundational electrical grid of your business that must be protected from custom wiring at all costs, or you view the external adapter layers as an equally daunting integration challenge, the way you architect your foundation today absolutely determines the limits of your operational agility tomorrow. We leave it to you to weigh the trade-offs and implications for your own organization's architectural decisions.